for you guys, you'll see chapter 6 is like really, really short. We only cover 3 sections. You guys are gonna miss it, but you're gonna get it when you guys come back. So, chapter 6 is a little weird because we actually start out, we're gonna start in 6.2, and then we're gonna go back to 6.1, and then we're gonna jump ahead to 6.4. Isn't that nice? Because
that's what she said.
it makes more sense to me to do it in that order.
Wait, is screencast over?
We're screencasting. Okay. The first part of 6.2 is actually stuff that we've done before. So remember, like the power formula.
The door's unlocked. Yeah, it is.
Oh yeah, I guess that helps.
The door's
Can I do
unlocked.
it?
Thanks.
I get extra credit, right?
Yeah.
Hold for sure.
Is there a spray?
There was. Oh, it's over there.
I did this yesterday.
How are you feeling?
I'm better. I've
Yeah.
still adjusted with the fever break, so that's good.
That's good. Okay. So just a quick reminder, these are really the only ones that you need to know. Did you see which ones I highlighted? I didn't want to highlight them too long because there's people taking a test. They're like, oh yeah, antiderivative for cosine and sine. I know, but, well, they have their calculators, it's fine, but I'm talking about, I have some regular that are testing.
That way.
The packets are up
Can you
here.
scroll up a little bit, Ms. Gleason?
No, for me.
Not for me, for.
Which ones, did you just need to see which ones I highlighted?
Yeah.
So for you guys, you need to know the power rule. You need to know the one with the -1 is the ln. And you need to know the antiderivative for cosine, sine, and secant squared. And you need to know the e to the x. Those are the only ones that you guys need to know. Then, did you highlight? Made note? Very funny. So,
Was that?
wait. When are you doing the test?
One.
When did we say?
Thank you.
I mean, should I not take it today? Thank you.
Okay, so when we did derivatives, we did the chain rule, right? We had to multiply by the derivative of the inside.
Yeah.
I know, so long ago. So
Neither.
for integrals, we learned the basics in the last chapter. This chapter addresses reverse chain rule.
Reverse
Okay.
chain?
So basically what we need to do, we're gonna learn something called U substitution. And U substitution, it's a little complicated. You actually have to have the derivative of part of the antiderivative in your integration. I know, we'll take it step by step. Wait, what? What? Okay, here, I know this notation looks a little complicated here, right? Just a little bit. Think of this as the outside. U of x, this is inside. And then you have here, derivative of the inside. So when you have a composition of functions, you remember what composition of functions would look like? Like for example, like if I said, let me give you an example. Let's say x plus 3 to the third. Actually, let's make that 2x plus 3 to the third dx. This is a composition of functions. we have what would be considered the outside function. What's on the outside? The outside is the cube, and what's on the inside? 2x plus 3. So we can't just say, oh, this is going to be 2x plus 3 to the 4th divided by 4. Okay, we can't say that any longer because the derivative of the inside is not equal to 1. Okay. This is where we use what are called differentials. So let me just explain differentials because I know we skipped some of that in
Chapter 3.
no, it was chapter 4. Let me explain. So usually when we write a derivative, like dy dx, so if I said dy dx is equal to x squared, imagine that if you multiplied both sides by dx, you would have dy is equal to x squared dx. This is how we would write out a differential. So you have your dy on one side and your dx on the other side.
Didn't we do that?
We didn't. We
did the
skipped
fraction.
over it. Yeah. So like if u is equal to x squared, then du is 2x dx. It's just like instead of writing du dx is equal to 2x, we jump right to moving the dx to the right side because we're going to incorporate the integrals. You'll find out more when we go through and solve them. And what about if u is equal to cosine of x to the third? Well, then du would be cosine of x to the, or sorry, let me do this in steps. What would be du dx? What's the derivative of the outside? Negative sign. Keep the inside the same, times the derivative of the inside, 3x squared. So then, if we move the dx over and just kind of rearrange a few things, this is what our differential looks like here. Okay, so far? What? Okay. So let's see what this one looks like. We want to integrate x minus 7 to the third dx. So in the beginning, I'm going to tell you what u is equal to. U, whenever we think of u, we think of what's on the inside. So if my inside part is x minus 7, so I'm going to let u equal to x minus 7. What would du equal? Wait, what's the derivative? What's the derivative of? What's the derivative of x? 1. And what happens to the 7? Okay, it goes away. It's 0. So it's really 1 dx.
Wait, how do you go from u to du?
Let me go back here. What's du dx equal? 1. So then du is really just equal to dx. Multiply the dx to the right side.
Wait, what about the cube part?
Okay, we're going to take care of that.
Oh.
So the whole point to this u substitution is we're going to substitute everything in, change it to u, integrate, and then we're going to plug back in for x. It sounds complicated at first, but once you see the steps, it's not that bad. Okay, so what do we have here? So we're going to rewrite with u. Okay, so I had the integral. Now, instead of x minus 7, I'm going to replace x minus 7 with a u. So I have u to the third, and since dx is equal to du, I'm going to replace it with a du. Now, why is that important? Well, we can't have these as different variables. If I have one variable here in the integrand, I have to have that same variable at the end. Yeah. Okay.
Thank you.
So,
I'll see you in a week.
all right. Have a nice trip. Okay. So, here's the thing with that problem. Basically what I did was we rewrote the problem, so it's no longer a composition, it's just a u to the third. how do you integrate u to the third? What's that going to be? U to the fourth. Good. And then plus c. Okay, because these are going to be indefinite integrals. Remember, what's the power rule for integration? You add one to the exponent, divide by that same exponent.
So wouldn't that be a 4 then we use the cancel out?
Oh, wait, are we given that u equals x minus 7? Or is
Yeah,
that
I
in the
gave
step?
you in the beginning, so you'll see
Well,
this.
that's a given thing. That's part of the problem.
I actually didn't like the problems from the book so much, so the first two sections, I made up a worksheet for you
See,
guys
I
to
didn't
send.
know. I thought u equals x minus 7 was the first step. and so
No, this is
that's a
part that
given.
usually.
That's part of the.
So this implies we have x minus 7 to the fourth over 4 plus c is our answer. So you just go back and replace everything with x.
So you replace x with u and then replace u with x again?
Okay, basically this is what you do. You take your inside, you do the derivative of that, then you plug everything in so that you don't have a composition, right? It was just u to the third, so we're just able to do the power rule. And then you plug back in what was the inside part, and you're done.
So du becomes c?
No, c is just a constant. Remember when we have an indefinite integral, we always put a plus c at the end?
Oh,
When we have bounds, we can figure out the actual value, but when we don't have bounds, we have to put in a plus c at the end.
Can you
Matthew?
repeat the steps?
Okay, so in this problem, du was equal to dx, but this is like your most basic u substitution.
God.
So
Basic?
this is basic.
Wait, what's basic?
Oh,
So let's do a few more so that you get, this is one of those things where you just need to see the problem a few times to get the practice, and you'll see that what looks to be very complicated at this point gets easier. Yeah, Preston.
The first step was take the
'Kay.
derivative of the inside.
Right,
correct?
okay, so step one, do you want me to write out steps?
Yes.
Okay, step one, find du. So if I have u as 2x, what is du?
Wait. du is,
Yep. We have to change everything to u at some point. So we no longer have a composition of functions. So what's the derivative of 2x?
2 times dx, right?
Perfect.
2 times.
Have fun on your trip. Okay, so second step is going to use substitution to rewrite the integral with u. Now, how can I do that? Well, du in this case is equal to 2 dx. I'm just going to rearrange something. Notice I have a 2 here and a dx here. So if I think of this as e to the 2x and then 2 dx, do you see how this is du? Right? Just look at it. It's 2 dx. 2 dx is right here. What was 2x equal to? Isn't that's our u.
So much anxiety.
So I'm going to rewrite this. Guys. Shh. So it's e.
2dx to du.
It's e to the 2x, 2 dx.
But isn't 2dx to du?
No, 2 dx is the same thing as du.
Oh.
Oh, I get it. Just making you a face. I get it.
What? Why didn't it go from 2 to
Okay, guys. Shh. What? I don't understand. Well, because 2 dx is the same thing as du. I'm replacing 2 dx with a du. I'm replacing the 2x with a u. So basically what I have is just e to a power. And these two variables, these have to match up. So that's why I had to change the dx to the du. And I had this 2 here, and it actually was very convenient that this is easily replaced with du.
Will it always work out like that?
No, just the first few examples because I made it that way.
Okay.
What's the antiderivative for e to a power?
E to the power.
E to the power. So it's e to the u plus c. Okay, so step 3 was integrate. with respect to u.
Why does that have anything to do with
And step 4,
Plus C.
substitute back in with x.
What do you substitute back in?
Okay, what did we originally make u
Oh,
equal
so
to?
e to the
2x. So it's going to be e to the 2x plus c.
Yes, what's the exact thing with the original equation?
Well, we integrated 2e to the 2x, and we got as our answer e to the 2x plus c. Again, I'm
Wait.
giving you I'm trying to gradually build up to more challenging problems. So we'll get there. Preston.
what happened to the 2 in front of the e 2x? See, 2 in the original.
Right, well 2 dx was the same thing as du. Remember?
No,
So the
like
2 went
going-
away.
Going back, the 2 in front of, like, after the integral sign.
Yeah,
integral
that was
to-
part of, the 2 and the dx was replaced with du. So the 2 goes away.
Oh.
Okay, remember those steps. First step, you got it memorized already? Sure. Okay, what's step 1? Find out what du is equal to.
Du equals 2x dx.
Yay. Okay, now,
Plug that in.
look back at your equation, or look back at your integral, excuse me. So notice that I have a 2x and I have a dx. Notice if I put that together, that's equivalent to du. So I'm just gonna,
So x squared plus 1 du.
yeah, I'm gonna rewrite it like this, and then 2x dx. So this is u to the 1/2, and this is du.
Oh, man.
No, it's okay.
You, yes, it's correct, Ben.
Why is it equal?
Wait, you don't check the notes, does that make me forward my own? We definitely check it.
Did you finish the first part?
Finish the first part, yeah.
Why? 2x?
Okay, why did I rewrite it as u to the 1/2?
Because you have
Oh,
to.
because the square
It's a square root. What was u equal to?
X
X squared plus 1. So I'm going to rewrite this. So step 2 is rewrite everything with just u.
So u to the 1
So it's going to be u to the 1/2 du. What happened to the 2x?
It's equal to du.
That's part of the du. That's why it went away and it just became, remember, our goal is to make something very complex. Right? Look at our original integral. We took something really complex and changed it into something very simple, just a one-step integral. So now if I have u to the 1/2, let's do the power rule. What do we get? U to the 3/2 over 3/2 plus c. Right, that's our power rule. And then just plug back in. The last step was, this is our answer with u, but we want to go back because we were originally working with x. And now we're going to plug that in. So here, our final answer is going to be 2/3 x squared plus 1 to the 3/2, and then plus c. And you don't need to simplify anything there.
will they always
it's fine.
cancel out? Like,
What you have there is
will it always cancel out, like the 2x and dx? How,
okay, dx is always going to go away. It's not always, I set up these on purpose to be nice, like
we have to
a
grab
nice,
this real
easy,
world.
like replacement. It's not always going to be that way. So we might have to compensate. Alex?
Okay, I understand the concept of trying to get high to get u to the 1/2, but can you do it step by step?
This one.
Yeah, the u to the 1/2.
Okay, what's u equal to?
X squared plus 1.
X squared plus 1. And it's raised to the half power. So I'm going to replace that with a u to the 1/2. 2x dx was equivalent to du, so I'm going to replace that with du. So you're just rewriting it. We're getting rid of all the x's, basically. We want to get rid of the x's, and we just want to have everything with u.
Do you care if we leave it as having 3 over 2 on the bottom, or 2 over 2?
I prefer the 2/3.
What if it's multiplication of 2 binomials?
Okay, so there are some cases where this u substitution won't work. I'm only going to give you cases where it will. So let's look at this next one. This next one, what's du going to be?
Sin x dx.
How about negative sine x? Remember, derivative. Now, look back at our original. I have a sine x and a dx, right? But I don't have a negative.
Pop in the negative.
Pop in the negative, basically. So, in other words, negative du is going to be the same as sine x dx. Let me just rewrite this. So I have e to the cosine x. I'm going to move the sine x next to the dx. This step is not necessary, but I'll do this because I know it's easier for you guys to see. So this sine x dx is going to get replaced with a negative du. Does that make sense? And what's this? E to the cosine x is actually just going to look like e to the u. Remember, we're getting rid of the x's. We're trying to rewrite everything so that it's just with the letter u. Okay, so what do you think we're going to do when we have a coefficient of -1?
Try.
Let's put it all the way out in front. Nice.
In front of the integral.
Yeah, so it's going to look like this. It's going to be e to the u du.
And that becomes.
And then how do you integrate e to the u? E to the u. So it's negative e to the u plus c. So my answer is negative e to the cosine x plus c.
Well, okay, is it gonna start getting hard now?
Only a little bit more.
Oh,
It's actually not that.
yeah.
Okay. Take a look at the next one. Okay. So du is 3 dx. Now, if you look at what I have right here, I just have a u to the 4th. There's no 3. Okay, so you're asking me what? So in the last problem, it was easy. It was just a negative, so we just put the negative in front. But when you have something like a 3, you got to get rid of the 3. How do you think about in like algebra 1? How would I cancel out that 3? What would I do to solve? I would multiply by a third or divide by 3. So this means 1/3 du is going to be replaced with a dx. So this is 1/3 du.
Oh, because we want to get dx on its
We're okay with that? It's kind of like you have to compensate. If you have something here with the dx, it's like we got to cancel it out right from the start. So we're going to cancel it out with a 1/3. We have to compensate. It's kind of like balancing the equation, if you will. So if we had a 3 with the dx, we got to multiply the du with a 1/3. But what are we going to do with a coefficient? Put it in front of the integral. It's just easier, then you don't have to deal with it. So what's our integral going to look like? 1/3 u to the 4th du. And then what happens with just u to the 4th? That becomes u to the? Good, u to the 5th over 5. Okay, so I have 1/3 u to the 5th over 5 plus c. The 1/3, you don't need to worry about multiplying that to the c. C is just a constant. So really what? Yeah. Yeah, I mean 1/3 times c is still just a constant.
Well, wait.
I still have that 1/3 out in front, right?
Is 1/3 also multiplying c?
Yeah, it doesn't matter. C is just a constant. So 1/3 times c is still going to be c. Okay, now I can replace everything. What was u equal to? 3x plus 1. So I have 3x plus 1 to the 5th over, what's my denominator? 15 plus c.
Why did you get rid of the anagram? Why did you get rid of the squiggle?
Oh, we got rid of the squiggle because we did the power rule. We did u to the 5th over 5.
Oh, that's what
Once you integrate, then once you figure out the power rule, you no longer need the squiggly.
Can you write that on there?
The squiggly is really an elongated S, but that's okay.
take the double derivative, the second derivative of an integral, you get the derivative.
Okay. Question? Okay. Are we all right with that now? Remember, in the beginning, I'm giving you what u is equal to, but once you get to the next few examples, then I'm not necessarily gonna give you, but I think you'll see it's kind of obvious at some point. It's just getting that practice. Remember, u is what's usually on the inside. So look at what's on the inside, 5 plus 2x cubed. Okay, so what's du? Oops. 6x squared. Good. And okay, I have an x squared, but I don't have a what? I don't have a 6. So you're going to multiply by 1/6 or divide by. Oh, what's going on here? Depends how they move. So du is 6x squared dx. So 1/6 du is equal to x squared dx. So if I think of this as 5 plus 2x to the third to the 1/2, x squared dx. So this is going to be 1/6 du, and this is going to be u to the 1/2. Right. So when I rewrite everything in simple terms, that's going to be, what do we do with the 1/6?
Front.
Okay, 1/6 moves to the front. And then my integrand is u to the 1/2. And then I just have du left over at the end. Remember, we're trying to make it simple to integrate. It's just going to be like the power rule, or e to a power, or sine or cosine or something. So how about u to the 1/2? That's going to become u to the 3/2 over 3/2. Are you okay if I write that as multiplied by 2/3 right away? And then plus c. Can my fractions simplify? Right, so this is 1. Right, so I get 1/9, and then 5 plus 2x to the third to the 3/2 plus c. Okay. Everybody's leaving. You know I'm still taking note of your hall passes. Okay.
Really?
Yeah. And when you go over 3, it deducts from your grade.
Do you
Okay.
let us know?
So let's what?
Do you let us know when you go over three, or you just have
Should I?
Alright, from now on, you're not gonna be happy.
I know. Pretty much half the classes pass their 3. Okay.
I haven't. Surprisingly.
I don't know, that one day that you left for like 10 minutes, that counts as 3. You left for like 10 minutes. Like,
He has a problem.
no. Okay. All right, guys. It's all good. It's all good. Okay. So when we went to integrate, and I did not tell you what u is equal to, we have to now figure it out. So what are we going to let u equal here?
U equals 2x minus 3 to the 4th.
No, just the inside part, though.
Oh, okay.
Okay. So if u is 2x minus 3, what's my du? 2 dx. I have a dx, but I don't have a 2. So what's that mean? Good. 1/2 du is going to be replaced with my dx. Is it okay if I just write it at this point, or do you need to see? So I'm going to put a 1/2 out in front, the integral, and then 2x minus 3 is what? U to the 4th du. Good? So it's gonna become,
1/2 u to the 5th over 5 dx.
and then plus c. Remember, we don't need any of the du or the dx anymore because once we integrate, we don't need the elongated s and we don't need the du or the dx. So this means, what do we have? 2x minus 3 to the 5th over 10 plus c. Now, if you wanted to check your answer, what would you do? Do the derivative. You would just do the derivative of this. Don't forget to apply the chain rule. Remember, the whole point of this is that it's reverse chain rule. So you would have the 5 moves to the front, and then this would come to the 4th, and then you'd multiply by 2 at the end, and you would see that you get back what you started with.
But is that what we start with? Is that the, if say we have y equals 2x minus 3 to the 4th,
Mm-hmm.
and this would be taken as a
Yeah, so if you want a quick way to check your answer, take the derivative of this. So that'll be 5 times 2x minus 3 to the 4th times 2. Okay, so, right, 5 goes to the front, 2x minus 3 to the 4th times the derivative of the inside. So does this end up, well, what happens with the 5 and 2?
Everything cancels. and
Ah,
you just get
everything
rid of that.
cancels, and you just get 2x minus 3 to the 4th, which is what we wanted. Oh, thank you. You see how you can just check it really quickly and then you can verify that you did it correct. Okay, this is tricky, but before we do this next one, I'm going to rewrite ln of x to the 3rd that way. So what would you let u equal to? What's inside? That's why I rewrote it that way. ln of x. So what's du? 1 over x dx. Do you see how right here?
What about the x on the bottom?
Okay, so x on the bottom is 1 over x. Let me rewrite this real fast. If I rewrote this as ln of x to the 3rd times 1 over dx, is that the same thing as what I have above? Yes.
Well, what if you didn't know that was
right,
zero?
this is, when you have x in the denominator, it's the same thing as 1 over x. So now you can see, what's this? This is du, and this is u to the 3rd. So I have u to the 3rd du. What happens when we integrate that? We get,
3u.
wait, no, just
3 to the 4th.
u to the 4th over 4 plus c. So now just go back and replace. I mean, that's what I'm saying. Like, the more you just practice them, I know some of them look really different, but it's this, the process is the same 4 steps.
What if you don't understand any of those things?
And you're in big trouble.
Yeah.
So is it
Then
ln of
step
x to the
zero.
4th over 4 plus c?
You want to try the next one on your own?
No.
Yes. Let's try it. Let's try it.
Well,
I
you-
can barely even write this down.
Wait, but which one's you? I don't know.
What's inside?
It's two.
X squared plus what half?
Okay,
So it would be x squared plus 3 to the 4th half.
to the negative 1/2 actually. Okay, what's du?
2x dx.
Okay, let me just rewrite what I have here so you can see. This is x squared plus 3 to the negative 1/2, and then x dx. So this is not quite matching up with what I have here. So it's going to be 1/2 du, and this is going to be u to the negative 1/2. So I have a 2x dx.
Oh, right.
So
just
I don't have,
divided.
right, whenever, basically what I want you to do, whenever you're like missing a number, multiply by the reciprocal. So if you have 2, multiply by 1/2. And then that 1/2 just automatically moves to the front because it's a coefficient. Okay, so how would we rewrite this now with you? So it's 1/2 in front. Well, look, I have it right here.
1/2
Wait,
u
why
to
would
the
they-
negative 1/2.
U to the negative 1/2.
Times 1/2 du.
1/2 du. No.
What, I'm sorry, Alex, you were asking a question? Oh, you got it, okay.
So then you get
Okay, so I have this 1/2.
1/2 u to the 1/2 power over 1/2.
Yay. And what happens to the 1/2s? They cancel. So it's really just u to the 1/2 plus c. So this implies what? What was u equal to? Go back to the very beginning.
X squared
I don't get which
x squared, the square root of x squared plus 3 plus c.
No.
I will say the numbers on
So are you going or no?
this page.
Oh, oh yeah, you have that.
Yeah, you have-
Oh, yeah, I didn't ask him.
There's only
Should've asked
12
Dr.
numbers.
Oh my god, that would have been so
Or
cute.
cubes.
No,
Or
we
one
don't
else
know
cube.
tubes. And then you both could have worn one of his cheesy shirts.
Yeah, oh, that would have been so I love his little cheesy shirt.
So would be
I feel like he has them.
x cubed plus x.
What? It's a cheesy shirt, so he probably has them just for cheesy because it's cheesy.
Oh my.
All right, now, this one, I think there was a question, like, what happens if you have like two binomials or something? I choose the one that has the exponent involved, which is this one. And this is how we're gonna check. What's the derivative of x to the third plus x?
3x squared.
Oh, and it's 3x.
Ah, so, what do you see right here? 3x squared plus 1. It will. I'm not gonna give you ones where it's not. So basically this and this combined is du. Right?
Yes.
Okay? If I take this part and this part and just rearrange it, that's really my du. So how would I write this in terms of u? Yeah, it's just going to be the integral of u squared du. So this very complicated integral turned into just the power again. Okay, so what do we get? U cubed over 3 plus c. And so now so the last step is the easy part where we just plug in. What was u equal to? Plus x to the third over 3 plus c.
Just realized how much my brain is banging over that.
Um,
Not out of compliment.
oh, because you're talking?
Yeah.
Yeah.
No, Sammy, that's exactly.
How far behind are you?
They're done.
Yeah, they're taking my.
Let's not finish that mistake. Let's not do that.
Yes. We're not going to do all of the topics that we have covered, but I'm happy to move this through. We're going to cover, so we have chapter 6 and then chapter 7 is just going to be a quiz, I think. There's only 3 sections.
Oh, you're done.
So we're going to do, chapter 7 is area between two curves and volume, but we're not going to do all the types of problems they do in AP. So it's just going to be like 3 sections and a quiz. But we'll get through, you'll get through all the topics. We just don't do the depth of problems. Okay, I'm actually going to skip this trig identity one for right now because I want to make sure we get enough. I want to get an opportunity to do definite integrals with u substitution. Don't want to miss out on that.
You're just skipping example.
This is, yeah, for right now. I don't even think you'll have to know it for, yeah, there is one problem. If you think I want to grade something on there. Okay, then.
I'll put on the.
Okay. All right, guys, so.
I was reading it.
Where's that put?
Anywhere. My stuff is so unorganized right now. Okay, use substitution for definite integrals. Let me just show you right here. The only thing that you need to know is that when you change everything to you change your bounds. The nice thing about this is, do you remember how like when after we integrated, we had to plug everything back in for x? We don't need to do that for this. We get to just substitute. Because if we change everything to u and we change our bounds, then we can just substitute, we can put the values in the way they are. Just trust me on it. It's not so bad. Okay, first thing we need to do is we need to establish what do you think will make u equal to? X squared minus 4. Okay, so let u equal x squared minus 4. So du is going to be 2x dx. Now, if I look back at my problem, I see that I have an x dx, but I don't have a 2. So it's going to be 1/2 du. If you think of it like this, 1 over x squared minus 4 times x dx, then you can kind of, right, if it's in the numerator, it can be moved out. And we could always make that 1 over. I was just rewriting it so you can, it makes it easier when we substitute in. Okay, now, these bounds, 0 and 1, these go with the variable x. What we want to do is we want to change these bounds so they are reflecting the values of u. So remember right here we said u is x squared minus 4. So I want you to find u of 0 and u of 1. In other words, take this, what you have here, x squared minus 4, plug in 0, what do we get? -4 and -3. So now when I rewrite this, my lower bound is -4, my upper bound is -3. Okay, so I just replaced where where 0 was, I placed a -4, where we had 1, I'm going to replace that with a -3.
Graph together, one using u and one using all that stuff, it would be the exact same.
They'd be the exact same. Okay, so now, remember how I had a 1/2 out in front? So I'm going to put a 1/2 here. And, right? Because this is 1/2 du, and this is going to be 1 over u. Let me just pause there, make sure you understand. No, don't. Don't. Because you weren't paying attention.
Yes, you were. Do you know I'm all on our phones?
Was it?
Sorry, not you. Okay.
Yeah, I was what? That doesn't mean I understood it.
Okay, the people that were fully paying attention, does it make sense?
I
Or
was fully paying attention.
sort of?
Are we ever gonna
You understand the 1 over x squared minus 4 becomes 1 over u? You understand where the 1/2 came from?
Yeah.
You understand where the bounds came from?
Are we ever gonna, is there ever gonna be a situation where, like when you plug the bounds into u, like they'll end up being negative, like they'll be switched, like the greater one is on the bottom and then they'll have to do the negative thing after that?
It could happen, but it'll
Like
take
that,
care of
it'll be
itself.
quick.
They could end up like that, but when you plug it in, it'll take care, the negatives will take care of
Oh,
themselves.
so we wouldn't change it yet?
You don't have to.
The brackets at the bottom
Well,
of the
one, three, plus
Right, so I have integrated, right? The antiderivative for 1 over something is ln of the absolute value, which is good because I have negative values here. So I'm going to have 1/2, and then it's going to be ln of 3 minus ln of 4. And you can just leave it like this. So notice here, because I left, remember I changed my bounds for u? I didn't have to go back and plug anything in for x. Because remember how we changed our bounds? then I was able to just plug right in. I didn't have to change u back into x. This one's kind of tricky, so I'll get you started on this. What's u? It's going to be actually tangent. Because what's the derivative? There you go.
Do we have to see this before?
So this is u, and this is du. Nice thing here, we don't have to worry about compensation, like we don't have any fractions to deal with here. So let's change our bounds. So 0 and pi over 3 go with x, but we want to change our bounds. So if u is tangent, what would be tangent of 0? And
The next one is 1.
no. What's tangent of pi over 3? Root 3. Unit circle. Okay, so let's rewrite it.
Have it on next.
Let's rewrite it. 0 to root 3. So now when I change everything over to u, what does it look like? Just u du.
And then
Okay, so what's u? If you have u to the first power, it becomes u to the second power over 2, evaluated from 0 to root 3. So we have root 3 squared over 2 minus 0 squared over 2. That's it. Okay. 4. Hi.
Oh, hi, Screen Cap.
I'm doing a siren.
I know, but then more problems I don't understand.
Whoa, what is
The
this?
more the merrier.
This is our homework.
Actually, we have plenty of time.
What? No, we don't.
No. I'm. I'm referring to, we have 2 days for this lesson. And we only have one example to finish. So technically, you have 2 days, you have 2 class periods to meet to finish. We have all week. No, you guys don't. You have a whole week.